analysis of variance. See, in regression and correlation, we tried finding out the relationship between two variables, right? Or probably when we did hypothesis testing, we did the comparison between two variables or two population data. But if there is a requirement that I have to test the means of more than two populations, if I have to test or compare the various samples and compare the means across the various samples where the size of the sample is different, and my comparison is each of the sample means, I'll compare it with the overall mean of the total set of samples. That is where I use the one-way analysis of variance. So the terms wise, people use the term as treatments. Treatments are nothing but different groups of samples, and for each of the treatment, let's say I have multiple observations. If you see in the example here, I'm talking about the three different cricketers. So the sample, the treatments are three different cricketers are three different treatments, and the runs scored by each of these cricketers is the various responses or observations of each of the treatments. The sizes of each of the treatments are different. Let's say if we see Dhawan, there are 8, 9, 10, 11, 12, 13 instances. Whereas when it comes to Rohit, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 are there. So which means the number of instances or the number of samples or number of responses for each of the treatment are typically maybe different also. But my intention here is to compare whether the mean of each of these treatments is overall in line with the overall mean of the three put together. In those kind of scenarios, we resort to a one-way ANOVA or one-way analysis of variance kind of a procedure. So going ahead, probably I will try to solve this one numerical using the entire concept of ANOVA. So that is where let me jot down the numbers so that we can do our entire calculation on this data itself. So let me take the data regarding the three cricketers. So we would like to work out on the complete ANOVA on these three. All right. So I'll take, let me just copy the data. Let's say I have this kind of a data for these three players. Now, in this, some of the key terminology we need to be comfortable with as a part of the ANOVA analysis for us is K. One is the K. This is the word typically used. This is the letter that is typically used to denote the number of treatments. So we have three different treatments. N. N is the total sample size, all across all the things put together. The total sample size is 41. So the sum of all. So probably we have some number for Dhawan, some number for Rohit. Like that, we have around 41 total observations that were collected. And when I say Ni, N1, N2, N3, which is the sample size of each of them. So there is 14 for N1, there is 13 in N2, and there is again 14 in N3. So this is one more thing. And the way we represent each of the individual observations, right? We represent each of the observations by Yij. So I represents the treatment here. So there are three treatments. So probably when I say Y32, it means the third treatment, second observation, which is nothing but 52. So please be comfortable with that kind of a terminology. So when I say Y27, which means the second treatment, seventh observation, which is 2. So like that we should be comfortable when we are doing this ANOVA analysis. Our intention is to compare whether the mean run scored of Dhawan is same as that of Kohli and Rohit. That is the major intention in this analysis. Is the average of each of these three players more or less the same, and is it equal more or less to the overall mean of the population? So those are some of the things we are interested in. So from that standpoint, couple of calculations that are required for us are probably the mean of the first one. The mean of the first set, if I take the average of this data, it is around 50.5. When I take the mean of the second set, which is mean of Kohli, the mean of Kohli comes out to 40.07, and the third mean, which is mean of Rohit, the mean number of runs scored by Rohit comes out to around 35.21. And I want to check out the overall mean also here, not just the three individual ones. I would like to compare the overall mean also, which is nothing but the average of all these values involved. So we have to add up all of them and compute the average of each one of them separately. So that comes out to around 41.97. So this is one aspect of our calculation. We find out the average. We find out the average in this kind of a model. We find out individual averages, individual means, as well as the overall mean of the entire data. Apart from that, we also compute what is called as the treatment effect. We call what is called as a treatment effect. So we can say the treatment effect of the one. The first one, whenever we use the word treatment effect, it is nothing but the individual mean minus the overall mean. The individual treatment mean minus the overall data mean. So the TE1 in our case comes out to positive 8.5. TE2 comes out to overall mean minus the individual mean minus the overall mean minus 1.89, and the T3 works out to 35.21 minus 41.97, working out to minus 6.76. Now one small thing you have to observe is these are the three treatment effects for the three players whom we have highlighted, and as per basic arithmetic, the sum of all the treatment effects should be equal to 0 itself. If I add up all these three, the sum of all the treatment effects more or less will come closer to 0 also. So this is a very small difference. And if there was no difference between the treatment means, then all of them would be same as the overall mean, which means the treatment effects across also should be equal to 0 itself. But in this case, there are some positives, there are some negatives, as well as for each of the treatment effects. and in some cases they are very high also. The treatment effect of 1 is around 8.52, whereas of 3 it is around minus 6.76. Now, now we'll go back to, if at all I have to use the ANOVA analysis, a few assumptions are there, right? In my data also, I'm assuming that the data, whatever I'm working out, it is following all these three assumptions. It is following all these three assumptions. The populations must be coming from a normal distribution, right? So I'm assuming that the data that I picked up for Dhawan, Kohli and Rohit internally is coming from a normal distribution itself. The variance for each of these three sets of people is more or less the same. Only in these cases, the ANOVA